Hello everyone, myself Bhagirath from LG Institute of Engineering and Technology. Today I discuss refrigeration system components. Okay, this is lecture number 19, part number 1. Okay, topic which I going to learn, there is a compressor, there is types of compressor which is used in a VCRS cycle or a refrigeration system. And another is a types of condenser which is also used in a refrigeration cycle. Basically, in VCRS or refrigeration cycle, mainly 4 to 5 types of component. One is the main component, that is a compressor, condenser, expansion valve, and evaporator. So, in this lecture, we studied types of compressor and condenser. Okay. So now let us start to explain compressor, what is compressor, and types of compressor. Okay. Compressor. Okay. We already know that what is the function of compressor. Basically, compressor or pump, both the function are same. Both the function are same. The function of compressor to increase the pressure. So as well as if pressure is increases, so temperature is also increases. So compressor increases the pressure of the fluid, but compressor can handle only vapor or haze form. Okay, but pump is handle only liquid. Pump handle only liquid. So pump is used in a VARS cycle. We see that the VARS cycle pump is used in a VCRS cycle. Compressor is used. Okay. So the function of the compressor basically is to increase the pressure of the refrigerant in the reference of refrigerant. Okay. It removes the low temperature, low pressure refrigerant vapor from the cooling coil through the suction line. Okay. Next, it compresses this refrigerant vapor by increasing its pressure and temperature, resulting in a increasing of the boiling point. If temperature or pressure of refrigerant increases, its boiling point of refrigerant is also increases. It discharges the refrigerant vapor at high temperature and high pressure to the condenser. It supplies to the condenser through a discharge. That is the main function of the compressor. Okay. Basically, compressors are mainly three types. First one is a reciprocating compressor. We already know that what is the reciprocating compressor. And second one is a rotary type compressor. And third one is a centrifugal type compressor. In centrifugal, the centrifugal force is compressed. Okay. In reciprocating and rotary compressor are more commonly used in a small capacities but lower evaporator temperature at low evaporator temperature. But centrifugal compressors are used at large discharge capacity. If you want to the say high pressure refrigerant transfer to the condenser, so it required centrifugal compressor. Okay, these are preferred for higher evaporator temperature applications like water chiller and air conditioner. In air conditioning, centrifugal compressors are used. They offer high efficiency, but these are the more expensive. This compressor, centrifugal compressor, are expensive. Okay. This is a layout diagram of single stage reciprocating compressor. We already know that the reciprocating compressor. The function of this is similar like reciprocating engine, but the supply of input is a change. In the reciprocating engine, supply of fuel to the cylinder and it burns, and that high mechanical work is obtained. But in this, mechanical work is supplied at high pressure refrigerant or fluid is obtained. Okay, how is it work? Here are suction or delivery. It is a delivery valve or it is a vapor inlet. Vapor is inlet here, and it is a piston and cylinder element, and it is connected to a crankshaft. The crankshaft is moved from with the help of the motor. That's why TDC to BDC, it moves of piston. That's why pressure is increases at the outlet of the cylinder. Okay, this is the layout diagram. This is a crankcase. This is a connecting rope. This is a cylinder. Outer body is a cylinder. This is a piston, and this is a delivery valve. And this is an inlet. Where inlet, okay, here refrigerant comes and it rotates. It moves from bottom dead to top dead. That's pressure is increases and it's outlet. Okay. Next, it is the during function. Pistons downward direction. So inlet of refrigerant comes in the cylinder and piston moves upward. That BDC to PDC. That compressed refrigerant is out or transferred to the condenser. Okay. Next is a rotary compressor. Rotary compressor is basically two times main type or one type of rotary type compressor. See here, just a rotor are used and it is a rotation with the help of motor, but it moves eccentrically with the help of spring-loaded vent. So here, 4 strokes is completed. Inlet of the function of this showing here. Here, 50% of suction is done. That time, also outlet of the refrigerant is open. Okay, this is 1% of suction is done. Here, 99% of suction, where total refrigerant is comes in this chamber casing and it rotates eccentrically. Because of eccentrically rotation, the pressure increases in the rotary type of compressor. This is the 4 process which are shown in this figure. Okay. Rotary type, this is 3D diagram or cross section of 3D diagram of the rotary compressor. Low pressure vapor and the high pressure vapor here. So suction takes place here, and during suction, the eccentrically this rotor moves this side, and then it goes to the discharge side. When it moves from here to here. So 4 processes are showing in this figure. Okay. Next, the 3D diagram of the compressor are showing in the figure. Okay, this is the 3D diagram of the rotary compressor. Okay, here 4 processes are showing 1, 2, 3, and 4. For refrigeration chapter, these types of compressor is not much more important except hermetically sealed type of compressor, which is used nowadays, and there is an important type of compressor which explained in brief. Okay, so here rotary compressor, this is a 4 dimensional strokes operations. This is a cross section view of rotary compressor. This is a housing, this is a cylinder, and this is eccentricity with the help of this spring, with the help of spring and blade, and this is a rotor shaft. Next, centrifugal type of compressor. Okay, centrifugal type of compressor. Here in centrifugal type of compressor, the refrigerant comes in the inside through this rotor side insert, and during motion of this rotor, so this kinetic energy is converted into pressure energy because of we use the diffuser ring here. Here diffuser rings are attached. Okay, fluid comes in this form here inside, and then through the motor or rotor we apply a kinetic energy. So high kinetic energy is transferred to this diffuser where pressure is increases gradually, and this is the outlet of the compressor. This is point number 2.22. Okay, so in cross section view, that is a casing, vapor intake, that is an impeller eye. That is an impeller eye, and there is a volute casing and driven shaft, and this is a impeller. Okay, this is a eye, rotor, impeller, and the casing. Okay, this is a screw type of compressor. Basically, this is like a gear. Gears are attached and motion. So refrigerant gases are trapped inside this chamber, and after motion, that is high pressure is discharged with the high pressure. Okay, suction from here, suction of refrigerant in form of vapor, and high pressure refrigerant will discharge through this one. This is connected to the motor. Here, 2 rotors in form of gear is attached to each other. Okay, this is a screw type of compressor. This is a screw type of compressor where in ring type of compressor, this is a revolving and orbiting screw, and so discharge pressure occurs, and high pressure we obtain high pressure refrigerant. Okay, how it is a rotor, because the motor is connected and orbiting ring is called rotation form. That's why we obtained high pressure because of refrigerant trapped inside this chamber, and refrigerant intake at low pressure from this side, and so here the motion of this ring, the refrigerant trapped inside, so pressure is increases and so it discharges upward direction. This is the our diagram or working. The refrigerant is comes inside and is trapped. Okay, this is its rotation line. So pressure is increases of the refrigerant. Next, very important, hermetically sealed compression. Why it is known as a hermetically sealed? Because motor and reciprocating compressor both are connected each other on a one shaft, and it is packed with the dome shape. It packed with the dome shape. That's why it is known as a hermetically sealed compression. It's a totally packed. No moisture is aided through the atmospheric, so it is closed with the dome, so it's known as a hermetically. Okay, this is our reciprocating engine, connecting rod, piston. This is a piston connecting rod and shaft, and this is connected with the motor on crankshaft. And here is a motor is attached. There is a winding, motor winding, and it is a motor rotor. Okay, motor rotor. And this shaft is combined with the bearing, two bearing. And in this motor is dipped into the oil for lubrication of the engine and motor. So how it is work? Okay, the suction low pressure vapor comes in this suction pipe and passing through the motor of this low pressure, the refrigerant supplies it heat to the motor where motor temperature drops. So the refrigerant also works as a coolant for the motor. So now this is going into the reciprocating compressor. Where in reciprocating compressor, pressure is increases because of it connected to the motor, crankshaft rotation. So piston up and down, TDC to BDC, so pressure is increases, and this high pressure is discharged to the discharge. Okay. This is the main function of the hermetically sealed compressor. Okay. This is the oil is used to as a lubrication. Okay. Oil is used to as a lubrication. Now, next topic is a condenser. We know that the condenser is a one type of heat exchanger which removes or extracts heat from hot vapor refrigerant and discharge from compressor to the expansion valve. The condenser is placed between compressor and expansion valve. The main function work as a heat exchanger which extract the heat from hot refrigerant. Basically, condensers are classified into three groups: air cooled, water cooled, and evaporative type of condenser. Air cooled, water cooled, and evaporative type of condenser. Okay, this is the for exam point of view, that is evaporative type of condenser is more, and condenser is also studied in the heat transfer subject. In heat transfer subject. Okay. First one is an air-cooled condenser. In here, the fins are like this one, and this is our pipes or tubes. In tubes, refrigerant are closed. Okay, the hot refrigerant vapor is closed inside the tubes, and the air is passed over this fin. So cold air is trapped inside this fin, so that heat is transferred from this hot vapor, this hot vapor, this hot vapor to the this heat is transferred from this cold air to the heat to hot vapor. That's why heat is exchanged between vapor and air. And at outlet, we obtain liquid phase changing with refrigerant. There is a liquid with liquid refrigerant is obtained. The plate type of fin is used. This is a plate type of fin. This is a tube in which hot vapor refrigerant is passed over. Okay, basically this is used in a low side pressure. Next, water cooled condenser. In water cooled condenser, water used as a fluid to cool the refrigerant. Here, the tubes are drawn here. This is the water tubes in which water is flowing, in which cold water is flowing upward direction. So cold water is flowing in these tubes. Okay, cold water is flowing in these tubes. Okay. And the refrigerant, hot vapor refrigerants in downward direction from here, okay, to in this forms. Okay, this is called tube and tube condenser. Tube and tube type of condenser. Tube and tube type condenser. So heat is extended here from hot vapor to the cold water. Okay, so it is a tube and tube type condenser. Next, water cooled condenser. Next, water cooled condenser. Here, cell and coil type, because of cold coil is used or tube is used for cold water, which is passing from this side to this side, and hot vapor is comes from hot vapor comes from in the cell directly, which is strike on this tube, so that warm water is obtained because heat is absorbed from this hot water to this hot vapor to the this water. Okay, so finally we obtain liquid refrigerant to receiver. Here hot water comes downward direction and obtain liquid refrigerant. Here cold water flows into the this tube and we obtain warm water because it absorbs heat from hot water. This is a cell and coil type condenser. Why it is cell? Because we use as a cell. Okay, as a cell. Next, water cooled condenser. This is a double pass cell and tube. Because double pass cell and tube, we use a cell in which tubes are inserted. So cold water is going into the tubes and out hot water. Okay, and directly hot vapor is strike over these tubes and we obtain liquid refrigerant to the receiver. Okay, so we use tube plates here. Next, very important, evaporative type condenser. Evaporative type condenser. Okay, this is the this is a cooling pond where water is filled. It supplies through a water pump to the nozzle. In nozzle, it is comes in a spray form. This is a cold water form of spray. Water nozzle is used to spray the water on the these tubes. In these tubes or coil, hot vapors, condenser coil, hot vapors flow in this coil and we obtain liquid refrigerant. And this water nozzle takes heat from this hot vapor, and this hot vapor is converted into vapor and flow away to upper side with the help of air in from this air levels. Okay, the air is passed upside because of due to density difference. The air is passed out to the atmosphere. Here, eliminator is used. To water particles separated with the help of this eliminator. Here, induced draught fans are used to absorb this water vapor or gas as a form, and it is out to the atmosphere. This is a very important type of evaporative because of water which is in liquid form and it vaporizes. That's why it is known as evaporative type condenser. Okay, this is a very important diagram which is nowadays used in most of the plant. That is an evaporative type of condenser. Okay, so thank you so much for watching this video.